Hi, in this video we're going to be looking at another classic linked list problem, which is to find a cycle in a linked list. So here's the Leetcode page, and looking at the problem description, we are going to be given the head, which is the head of the linked list, and all we need to do is to determine if there's a cycle in the linked list. So the description says that a cycle in the linked list occurs when there's some node in the list which can be reached again by continuously following the next pointer. So internally, the POS is used to denote the index of the node that the tail's next pointer is connected to. So this POS, which is the position, is not passed as a parameter. So for example, what this means is that if you're going to follow this, so 3 and the next points to 2, next points to 0, -4, and -4 points not to none, which denotes the end of a linked list, but it actually points to 2. But we have already visited this node before because we traversed from 3, next was 2, but after -4 we come back to 2, and this means that there is a cycle. So again, we're looking at example 2, we can see that 1, 2 and back to 1 again, and 2 again, and it just keeps going on a cycle. Example 3, it's false because it's just one node and there's no cycle, and this actually points to none because there's no next node, and that means the linked list will just end there. So it's just a single node in a linked list. So based on this, how can we approach this problem, right? So in a previous problem, what we saw is that we actually found out the middle of a linked list using a runner technique. So we're going to apply the same technique here. And this technique, while I call it the runner technique, the actual algorithm is called Floyd's cycle finding algorithm. And what this involves is to actually have two pointers. The first pointer is called slow pointer, and the second one is called fast pointer. What we're going to do is that we are going to increment the slow pointer by 1, and we are going to increment the fast pointer by 2 in every iteration. So the concept here is that if the slow and fast pointer meet at any point in time, that means we have found a loop in the linked list. Else, if the pointer actually reaches the null node, we stop because we have actually reached the end of a linked list. So as long as there's a cycle, we won't be able to find the end of a linked list, which is denoted by none. So given this algorithm, let's go ahead and code it out so you can see what I mean. So we have a fast pointer which is pointing to the head, and we also initialize the slow pointer which is also pointing to the head. Now we are going to start the while loop, and our conditions here are going to be pretty straightforward, right? While there is existing a slow pointer that is not none, so while we can write this, while slow essentially means that as well. So while slow and fast, but we also need to add a third condition, which is fast must have a next pointer. So all these three pointers must not be pointing to none for this condition to be fulfilled. So while these conditions are met, what we're going to do is to increment slow by 1. I'm going to increment fast by 2. So next, and then another next. And if at any point in time, if slow pointer equals to the fast pointer, both of them are actually pointing to the same nodes, this means we have actually found a cycle. And if the entire iterations all execute successfully, and they actually reach a point where the slow, fast, or fast or next points to none, this means that we have reached the end of a linked list, and that means we do not have a cycle. So I'm going to return false. So let's actually think how this algorithm will actually work on the examples given. So here we have a slow pointer and fast pointer pointing to node 3 here, and in the first iteration I'm going to increment the slow pointer by 1, which means it points to 2, and the fast will jump twice, which means it points to 0. Next iteration, slow jumps by 1, fast jumps by 1, 2. Next iteration, slow jumps by 1 and fast jumps by 1, 2. And now you see this, what happens is that the slow and fast actually meets, and because we have a condition that checks if slow and fast is pointing to the same node, what we're going to do is that we're going to return true, which means we found a cycle. So that's exactly how this algorithm works. Let's go ahead and run this code. So this code has been accepted, and let's try submitting this. And again, it has passed all the test cases. So once again, this is the runner technique, also known as Floyd's cycle finding algorithm, which helps us to find if a linked list has any loops or cycles. So I hope this video was really useful for you, and if it was, do give me a thumbs up and subscribe to my channel for more upcoming videos. I'll see you guys in the next video.